Two key concepts for marginal cost and average cost. Again, we talked about marginal product. Marginal cost is the same idea, looking at the total cost, going from one product to a second product for the total cost and subtracting that, and that will give you your marginal. So anytime you see the word marginal, it's going to be a difference from one to the next. As in the case of marginal product, it says marginal cost is equal to a rise divided by the run. So there's kind of the mathematical equation for it. And here's another nice chart for you as well. And again, not too unfamiliar to you. It's going to be the same as what's in your packet that you have. But you have fixed plus variable equals your total cost. So you have your total cost. Well, what's the marginal cost? And that's looking at going, again, from 0 to 1 or 1 to 2. So these are the number of salsa cases that they could be producing. So if I go from 1 to 2 cases of salsa, it was 120. Going to the second one's 156. Well, what's the difference between those? Well, it's $36. Or if I go from 2 cases to 3 cases, what's the difference in total cost? Well, then it's going to be $60 and so on. So that's your marginal cost. So again, these are all things that you should be able to find. It might take a little while to remember all these different definitions for fixed, variable, and total and marginal, but with practice, we'll get it. And here's just again another graph, just says the total cost for Selena's Gourmet Salsas, and then the marginal cost curve is represented as well. So it says for a second case of salsa increases by a total of $36, and as we saw in the chart before, the 8th case of salsa would increase by a total cost of $180. So why is the marginal cost curve upward sloping? And again, these ideas are kind of similar to the demand curve and why the demand curve is downward sloping due to diminishing marginal utility. Well, now we're looking at the supply curve and why is it upward sloping? And here it says because there are diminishing returns to inputs in this example. As output increases, the marginal product of the variable input declines. This implies that more and more of the variable input must be used to produce each additional unit of output as the amount of output already produced rises. And since each unit of the variable input must be paid for, the cost per additional unit of output also rises. More cost curves here. So here's the average cost. The average total cost, often referred to simply as the average cost curve. So sometimes I label it ATC or AC. It's the total cost divided by the quantity of output. So anytime you see the word average, you should know you need to divide, just like in your math class. If they ask for the average of something, you're obviously going to divide it by something. So it's just the total cost divided by the quantity. It's U-shaped, and so the total cost curve falls at low levels of output, and then it starts to rise at higher levels, and looks like a U. The average fixed cost, though, if you are just looking at the fixed cost, is the fixed cost per unit of output. So that would be, again, since it's average, it's just dividing. So it's fixed cost divided by the output. And as your output increases, your average fixed cost will get lower and lower since you're dividing it by that number. So if your output gets larger and you're dividing that same number, that fixed cost divided by a large amount of the quantity, then that number is going to get lower too. And then another one, average variable cost, is the variable cost per unit of output. So it's your variable cost divided by the quantity, and that's your average variable cost. And you can see each of these columns here. So total cost, if you want the average total cost, it would be simply 120 divided by 1, 156 divided by 2, 216 divided by 3, and so on. That would be your average total cost. And then you have your average fixed cost, which is the fixed cost divided by your quantity. And then you have your average variable cost, which is going to be divided by the quantity as well. So if we were to graph this is the average total cost. When I graph it in class, I probably make it a little bit more U-shaped than this, but this is okay. And so there's the minimum of the average cost curve, and I'll go back to that real quick. As you can see again, when there's lower quantity, it's falling, and when there's a higher quantity, the average cost is going to be increasing. And so we're going to kind of concentrate on that minimum average total cost curve. So if we put all the cost curves together, it says the marginal cost is upward sloping due to marginal returns. And again, that's not unlike the marginal utility that we talked about with demand, but now we're talking about supply, so that's why the supply curve is upward sloping. The average variable cost also is upward sloping, but is flatter than the marginal cost curve, so it's always going to be below that. The average fixed cost is downward sloping because of the spreading effect, because it's divided amongst more output as you keep, if you're dividing 400 by 4 or 400 by 8, that number's going to get smaller and smaller. And I think number 4 is probably the most important one. It says the marginal cost curve intersects the average total cost curve from below, crossing it at its lowest point. And this last feature is our next subject of study, it says. So it's really important, and that's going to be something you'll be graphing in the chapters to come. And you'll have to remember that the marginal cost curve always is intersecting the average cost curve at the minimum point. And here's all those curves together. So you have your marginal cost curve, which is upward sloping, which is the same as your supply curve. You have your average total cost curve that's U-shaped, and the marginal cost curve intersects that minimum point here where it says M. And then you have your average variable cost curve that's below it. And then you have your average fixed cost here. As you can see, it continues to decline, as I said before, as you divide it over more and more output. So the average total cost is always going to be above the average fixed cost and the average variable cost, because you add these two together, and that's how you get the average total cost curve. So average fixed plus average variable equals average total cost curve, so that curve is always going to be above it. There's a lot of information, is it? I know. We're going to practice this in class, and I think this will make more sense when we actually get to the market structures, but we're just kind of looking at the background of this stuff, kind of the mathematical part of it and why they look the way they do. And we're actually going to get rid of most of the numbers when we get to the market structures, and we just are going to graph what would probably happen, and we don't have to necessarily have all those numbers. So I think it will get easier, but this is good background information for us. And again, this talks about the bottom of the average cost curve and the marginal cost intersecting that point, which will always happen. And here it says the minimum cost output is the quantity of output at which average total cost is lowest, the bottom of the U-shaped average total cost curve. And that's where the average total cost is equal to marginal cost. If the output is less than the minimum cost output, then the marginal cost is less than the average total cost, and the average cost is falling. And if the output was greater than the minimum cost output, marginal cost is greater than the average total cost, and average total cost is rising. And so you want to be at that point where the minimum cost output is average total cost is equal to marginal cost. Mathematically, that's the only place that it's going to work. And here again, the marginal cost curve is intersecting the average total cost curve. And then this is what I just said earlier. It says if marginal cost is below average total cost, the average total cost is falling. And if it's above, the average total cost is rising. So only at point M here is it equal. And finally, we're getting on to our last concept here, so hang in there. And this is going to look at short run and long run average cost curves. And so in the short run, the average cost curve is U-shaped like I mentioned before, but we would like to keep our costs low. We don't want them to keep going up. So when we go from the short run to long run, one of the differences is that, remember, everything becomes variable. I can change the number of factories that I have, and so I could actually make yet another factory leading to another short run curve or average cost curve and keep lowering that price. And then when that starts going up like that, maybe I could buy yet another factory or new machinery to try to keep those costs down. So we're going to look at each of these points here and divide this U-shaped average cost curve up. And so what we'll look at is called economies of scale. And so this curve here is the first part of the average cost curve. Again, if you remember, the average cost curve I said was U-shaped, so this is the first, third of it, I guess. And in economies of scale, it says as I double all my inputs, so if I double the marshmallow cream, the knives, and the plates in the factory, I'm actually going to produce more, or the output more than doubles uh, than what I had before for the number of greebies. So I double all those things, I more than double my output. And bigger companies are able to take advantage of this. I have the picture of Macy's here because they had, bought out Dayton's or Marshall Fields, and they're able to do that because of economies of scale. Costco is able to do that too. It's these big companies are able to do that and take advantage of it because they can take a hit early on and still survive, and then actually make money off of it. Where mom and pop stores, they can't do that. They're not going to be able to take that hit. They would go out of business. So these bigger stores can do that and offer prices at a lower price than mom and pop stores. In constant returns to scale, as I double the marshmallow cream, the knives and the plates and all that kind of stuff in factory, the output would also exactly double. So this part here is the middle of the U-shaped average cost curve. So this is the middle section of it. And sometimes that can also be called constant returns to scale. And then the last third of the average cost curve then is upward sloping, and that's called decreasing returns to scale or diseconomies of scale. Don't you like that there seems to be two names for everything? When all inputs double, the output less than doubles. And I kind of mentioned the mom and pop stores already, but they're not able to take advantage of the economies of scale like big companies can. And so it's very hard for them to double their input because they would actually lose quite a bit of money because their output would less than double. And here you're going to see them all together. So there's the first third, and then the middle one, and then the last third. So if you connected all those, you'd have a U-shaped curve, an average cost curve. And that is finally the end of the presentation. Aren't you glad you didn't have to write down every single thing? I think you have a really nice teacher. You should thank him tomorrow.